So to review what we've done so far in this course for electronics was that we learned that in series, and a series is not where we are now, we're on parallel now, but in series, if we added all the voltage drops up, it would add up to what our voltage total was. Now, in this class, the fact that we got 1.5 for each of them in a 6-volt circuit just meant that our resistances were all the same. It's not going to, with different resistances, all have the same voltage drop. The amount of energy needed to get through these is related to how much opposition to that current flow that there is. Current in series was all the same. Resistance, you add them up, same as with voltage. And then last week we did voltage in parallel. And last week what we learned was voltage is going to be the same throughout. So where do we see that? We see that in our household when we come from a breaker box and we run out to different outlets that we have. Like in the class we had the 2 outlets there. Each of those outlets had 120 volts supplied to it. It didn't have to divide the 120 volts between the 2 separate outlets, sets of outlets. It didn't have to divide them into 4 because there were 4 different outlets for both boxes there. Because they were in parallel and we had ways, we had the jumper wires on there with the wire nuts, and we were allowing the current to get each place individually without having to go through something. Then that's how we're able to get that in parallel and to make that voltage be the same everywhere. All of your receptacles in your house are going to be supplying 120 volts. So now I want to do a lab where we're going to talk about what current does in parallel. And so what you're going to be turning in to me next week is you're going to turn in this statement right here with what should be in between I1 and I2 and I2 and I3 and then afterwards, for etc. Okay? So that's what we're trying to get out of this next lab that we're doing here. So, measuring current at multiple locations in a parallel circuit. Set up a parallel circuit that has 3 lights in parallel and draw the schematic. Okay. 3 lights in parallel, I'll draw a schematic. I'm going to put some paper below this because otherwise it just gets dark on the other side. So, draw a schematic for 3 lights in parallel. So we have a power supply that's giving us 6 volts. Comes out L3, and then we're going to have 3 other branches here. L1, L2. Now, you see also we have 3 branches, 3 lights in parallel. If we had put another light bulb in here, right after, let's say after L3, we had put a light bulb in here at L4, would we have 4 light bulbs in series? Or would they be in parallel, 4 light bulbs in parallel, or would it be L and 2 be in parallel with 3, 4, which are not in parallel but in series together? Okay, something to think about, which we're going to be getting into eventually here. But we've drawn a schematic now for a 6-volt power supply with 3 lights in parallel. Now place the ammeter in series with, okay, so let's set that up. 3 lights coming from a 6-volt power supply. So from our power supply, we come from the negative side, and I can draw that on here too. Negative, positive. From a negative side to L1. I'm going to clip into the side here so I don't have to worry about it popping out on me all the time. Okay? Now, from there we got L1, and L1 we can go to L2 also. So I'm going to have another wire, try to find my shorter ones here, that I can clip to from here to here. So now our negative comes out. It can go to L1 or it can go to L2, and this all before it goes across here. Or it can come from L2 to L3. So right now you can see there's kind of like jumper wires like we've done in the residential wiring. From our negative we can go negative, blah, 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 all through those, and then we want them all to go back to the positive side of the power supply. So I'm going to take all these, I'm going to join them together through conductors. Okay? And then I'm going to give that a path back to the positive side. Does it matter if I connect it from here? Does it matter if I connect it from here? Does it matter if I connect it from here? No. Because anyway, since they're all connected here, from any way back, they're all going to be able to have a return route. So I'm just going to go right to the middle. Here's a good spot to hook on, and I'll clamp that there. Okay? So now we have set up a parallel circuit with 3 lights, all in parallel, a 6-volt power supply. Now place an ammeter in series with L1 only. Okay, now this is very tricky for a lot of people here. So the ammeter is going in front of L1. So if I were to redraw this, and I'm going to draw it down here where you can see it, right underneath this. I'm going to finish out this schematic. L3, and then it's going to go back to the positive side of the power supply, right? So from our negative side here, we want to come out, and we want to get to an ammeter, 2, and 3, right? We don't get, from our negative power supply, we don't get directly to L1. There's an ammeter that's in series with L1 before it. So here, we have our negative coming out. We want our negative to be able to get to, our negative to be able to get to L2 and L3, right? And we also want our negative to be able to get to the ammeter. So, from our negative also, I'll take this wire here, and I'll connect that up. So that's from negative also, it's coming from. And I want to hook that up to my multimeter here. So I'm going to set this to current. Okay. Well, we may have to change our range here. We'll see how that works. But we want to be going from the negative, right here again, from our ammeter, or from a negative to the ammeter, L2 and L3. So from the negative to our ammeter, the negative side of my ammeter, and from the positive side of my ammeter, I want to go to L1. So you see what's happened here. The negatives come out, it's gone to L2, L3, my ammeter. When it goes through my ammeter, then it goes back to the circuit here. Now let me see if I have to. Oh, I have to make sure I'm in measuring current. Sorry, I had it on the wrong job here. It has to be on direct current. Okay, so right there I'm set up and I'm getting 330 milliamps. 330 milliamps, which would be 0.33 amps, right? 1, 2, 3 for 330 milliamps. Okay. All right, so that's the first one. Next one says, place the ammeter in series with all 3 lights. The junction would look like this. So now with this schematic, we have L3 here, comes over, rejoins, down, down. So now we have the ammeter, or sorry, the negative of our power supply comes out and goes into the ammeter before it gets to any of the lights. Okay, so this time we have our negative. And I'm going to try to take things apart a little bit more so we can see what's going on with this perhaps a little bit better. So now we have the negative from our power supply goes right to our ammeter. So the negative from the power supply goes right to the negative side of my ammeter. Remember, here's the ammeter. Make sure you have that in the view here. You can see that. Okay? So there's my ammeter. I'll put it here so you can see it better. Okay? Negative from the power supply goes to the ammeter. Negative power supply goes to the ammeter. From the ammeter, we go to 1, 2, and 3. So from the ammeter here, we should be able to get to, so I'll leave that on. From the ammeter, the positive side, we follow this wire, and it goes to 1. I want it to go to 2. And 3. So the negative side goes to the ammeter. From our ammeter, we go to 1, 2, and 3. And then all go back to the positive side of the power supply here. Alright, now let me see what I've done here. Make sure I'm hooked on well enough to all this stuff. Okay, they're not very bright. You can see that they are running right now. The lights are on, but it should be brighter than that. So our negative, again, comes out to the negative side of the ammeter. We're in amps, direct current, from the negative side, goes through the ammeter, over to the positive side of the ammeter, and then to L1, L2, and L3. So I should be getting a number here. 3 milliamps. That is not correct. Ammeter, from the ammeter to 1, 2, and 3, and I apologize, guys. I'm not using my meter that I'm accustomed to using here. I don't measure current with this meter very often.